What's happening inside a real fax machine is surprisingly similar. There's a sensor that reads a line at a time at the sending end and a printer that prints out a line at a time at the receiving end. The lines are usually much too small to be visible, except at the tiny writing at the top of a fax, which identifies where it's come from. Of course, there's a mass of electronics underneath that converts the lines to sounds that can travel over the telephone, but the basic idea is exactly the same as our human fax. It's so simple, it was first patented 150 years ago, long before the era of electronics, and over 30 years before the invention of the phone.
You are about to witness a race between the Xerox telecopier transceiver and Speed Johnson, one of the fastest messengers in the world. They will both attempt to get a copy of this important document to a destination at the other end of the city, and they have to get it there in 4 minutes or less. Okay? On your mark, get set, go! Speed will be using an ordinary motorcycle, the telecopier, an ordinary telephone.
By the 1960s, electronics had advanced enough to revive interest in office fax machines or telecopiers. They were very expensive, slow, and different manufacturers' machines were all incompatible with each other.
The telecopier copy has just arrived, ladies and gentlemen, in exactly 3 minutes and 57 seconds.
The development that really made the fax machine practical was the digital fax. This not only split the image up into lines, but into a complete grid of tiny squares. So first you have to put a grid over the image, and then decide which squares are going to be white and which squares are going to be black. That's what I've done down here. Well, now I can send this to Rex just like I did at the beginning of the program, square by square. The only difference is that this time Rex needs an assistant, because Rex is going to have to look at what he's doing to get the paint exactly in the squares. He's got a similar grid with the squares marked out just like mine. Right. Okay.
Stop! Black! White! Black! White! Black! White! Black!
The big advantage is that Rex should be able to reproduce exactly what I'm sending. Even if I hold my flag up at slightly the wrong moment, Rex is unlikely to fill in completely the wrong square. It's this precision that makes it possible to send digital faxes much faster without losing any quality in the reproduction. A mathematician called Huffman worked out all the possible codes for the different run lengths of black squares and white squares. And he gave the shortest codes to the most common run lengths on an ordinary typewritten letter. If I put a mask over a line of the type, hold a magnifying glass over it, you can see that there are a lot of thin black lines. These are actually each 2 squares wide, and if you look on the Huffman code, you can see, because this is very common, it has a very short code. If you look at the white spaces between the lines, you can see they're all much more variable in width. So all the white spacing have longer codes. This is the same idea as Morse code, where the vowels have shorter codes than the less common consonants. And this explains